Hello, everyone. Welcome to our presentation, our Capstone presentation. So our topic is semantic communication over satellite networks, and our group members, me, Chibuzor, Pramod, Lakshmi, and Deji. So we will be doing this presentation on semantic communication over satellite networks. I'm going to hand it over for the introduction to Lakshmi.
Yeah, hi, how are you? Like, so the introduction part is the increasing the number of satellites, based on the images and the communication technologies has been created and increased and demand of effective transmissions of massive pictures and data while one which considers satellites network traditional images or comprehensive approaches such as JPEG and JPEG 2000 can be provide some comprehension but frequently fail to capture the high level semantic communication formation included in the pictures. Uh, this can be lead to a wasteful use of allowable bandwidth and a poor image quality after transmission. The objective of the of this research to be a develop a LQ semantic communication system that makes effective use of vision and transformation suites to encode the transmit high level semantic communication across the satellite networks. So, and for uh, uh, and next segment is like a problem statement. Increased demand of efficient satellite data transmissions. The proliferation and satellite-based imaging and communication technologies has led to a surge in the volume of a picture data that needs to be transmitted over satellite networks. The next point, eliminations of traditional comparison techniques, conventional images, and comparison methods JPEG and JPEG 2000 are effective in reducing the file size but often fail to retain a high level semantic information in images. In efficiency of bandwidth utilization, the inability to capture the transmit semantic information efficiently results in a wasteful use of valuable which and degradation of image quality during transmissions. And the next one is motivation. So, need for high quality image transmissions. There is growing to need for transmitting images with the high quality, high semantic fidelity over satellite networks for applications such as remote sensing, disaster management, and telecommunication, and potential of vision transforms. With have shown the promise in capturing high level semantic information in images and making them suitable for improving the efficiency of satellite image transmissions and enhanced efficiency and effectiveness. Developing a semantic communication system using WIT uh, could sufficiently enhance the efficiency and efficiency of satellite-based image and communication systems. Um,
Good day, Professor. Thank you very much for giving us rather the privilege to talk about the semantics communications over satellite network. I'll be talking about the data collection. The dataset collection, it involves gathering and compiling various datasets that contain information relevant to the semantic communication objective. And the dataset, they serve as the foundation of enriching and transmitting the data over the satellite communications. And the data set includes the identify the relevant data set. That is to say, it determines the type of data set needed for the semantics communication application. Also, the satellite imagery data set. It obtains satellite imagery data set from satellite imagery provider or repositories. And this data set may include optical imagery, radar imagery, and so on. Also, we have the capture sensor reading, like an access dataset generated by sensor deployed on satellite ground station. I'll move to the next, which is the model design. It is the primary component of the proposed system. That is the vision transformation. That's a VTI model that is taxed with the encoding and decoding the semantics information of pictures. And also under it, we have the semantics representation, which is defined as a standardized way to present semantic enriched data. This also can be involved in using autonology languages like RDF, which is Resource Description Framework. Also, we have the data transmission, which is determined how semantically enriched data will be transmitted over the satellite network. Also, this involves encoding the data in a format suitable for transmission, such as the JSON or the XML. We also have the security and privacy. It implements security measures to protect the confidentiality, integrity, and authenticity of the semantic enriched data transmitted over the network satellite. Then I go to the third one, which is the proposed approach. It involves the several key steps to enable effective transmission and interpretation of data. We have the transfer learning, data augmentation, like also we apply various data augmentation techniques, including random cropping, flipping, and color jittering to increase diversity of the training data. And also the irregularities in compression regularization techniques such as the dropout and weight decay. Also, we have the optimization and employing the advanced algorithm and learning rate scheduling to accelerate convergence and to achieve a better performance.
Yeah, hello everyone. I'm saying about modal architecture, and this is divided into four certain parts. And one is vision transformation, and the second one is channel encoder and channel decoder and vision transformation decoder. And the vision transformation helps in the in the encoding of images which we input with a semantic meaningful representation with the high level semantic information. This helps in the removing of redundant and irrelevant details. And coming to the channel encoder, a channel coding module responds for encoding the compact bit representation into suitable transformation over the satellite channel. And coming to the channel decoder, a model that decodes the signal from the channel and recovering the bit transformation, which helps to decode the images. And coming to the vision transformation decoder, the trying to reconstruct the original images from the decoded bit representation. and with the high level semantic information and essential details, which helps for the blur images to convert into the normal images. Here is a model architecture flowchart, which helps when we get the input images, and it helps to train the more train module, and the both, and the images which suitables for what we run, it goes to the images like wit encoder and wit wit decoder finally, and we can decode the images. Yeah, next I'm passing to the Jbros.
Hello, everyone. My name is Shibuzor. So I'm going to talk about like our results and analysis from the project. So one of the things we discovered was that the VIT encoder generates like compact representation. So it captures the essential information of the images, and then it brings out like higher compression rate ratios compared to the standard image compression methods that can be used. So the VIT decoder can then rebuild the pictures from those representations while ensuring that the high level information and features are retained. So using those simulated satellite channels with different bandwidth restrictions show system can like it sends the picture data effectively, and then it also preserves the image quality at the receiver end. So that means that when the information like is sent and received, the quality is preserved and the essential parts are preserved while enhancing the image. So we can see that in the results and the analysis. So the original image is very much blurred. So when we process the image and like decode the image, we get a much clearer image. So this is from the cipher data set. These are sample different images. So there are different images in the data set. So we get those images, and then when we run the processing and the decoding, we see that the image quality is significantly improved compared to the old one. So these are additional images as well. It also improves the image quality, ensures that everything it ensures integrity of the images while also improving the quality. That's pretty much what our code does for the vision transformer. That's what the code does. So basically, we can basically when we use a semantic VIT, we can what we're trying to say is that this this code can pretty much like it can help to preserve image quality and help to transform it in terms of like making the quality look better. And to conclude, we can see that our objective was to create like an innovative system that uses a vision transformer to send effectively high level semantic information with limited capacity. So when we implement the results, we see that the system has capability to achieve subsession compression ratios, and then maintains crucial information, which I already explained. So when the important information is always retained while also ensuring that the image quality is significantly improved. So this is like the code. So this is like so if you see the code, it has like all the different information and like information on how to what the different modules are of the code are doing and the different like parts of the code. So we divided it. We have the multi-headed attention mechanism. We have the VIT encoder. We have the VIT decoder, pre-process images, deep process images, the encode image function, decode function. So we define the different parameters as well. And then we also have to create our model. And then we load the data set. So we load it with the different, like we use the different parameters for the data set as well. And then we show the original images, and then we show the decoded images as well. So you can now see that the video transformer helps to improve the image quality. All right. Thank you very much for listening. We hope you're able to understand the project, and I hope the project has made sense and you have been able to learn really important things from our capstone project.